So hello everyone, today we have a question from GATE 2026 electronics paper. In this question they are asking about the density of electron diffusion current. The problem with this question is that in the official answer key released by IIT Guwahati, they have mentioned the answer to be 35 amperes per millimeter square, which is actually wrong. The correct answer should be negative 35 amperes per millimeter square. In this question they have nowhere mentioned about the magnitude. They are simply asking about the density of electron diffusion current. That means we have to consider the magnitude as well as the direction. So this is going to be the correct answer to this question. Why it is so? Let's see. In this question they have given the concentration of electrons at x equal to 1 micrometer and at x equal to 4 micrometers. So this is x equals to 1 micrometers and this is x equals to 4 micrometers, and this is the concentration per centimeter cube. At x equal to 1 micrometer, the concentration given is 2 into 10 raised to the power 17. And at x equal to 4 micrometers, the concentration is 10 raised to the power 16. And it is given that this concentration varies linearly. So it is going to be like this. So here we have electrons, 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 electrons. We can clearly see that the concentration at x equal to 1 micrometer is higher than the concentration at x equal to 4 micrometers. And we know that the diffusion of charge carriers occurs from higher concentration to lower concentration. So the electrons are going to diffuse like this. That means the electrons are moving from left to right. And if electrons are moving from left to right, the conventional current has to move in the opposite direction from right to left, which is the negative direction. That is why in the starting of this video I told that 35 can never be the answer to this question. The correct answer is always going to be a negative number. Now let's find out its value. So what's given is the mobility of electron, which is 1400 centimeter square per volt second. And the thermal voltage to be 25 millivolts. So mobility mu n is 1400 centimeter square per volt second, and thermal voltage Vt equals to 25 millivolts. Now we are supposed to find the value of density of electron diffusion current, which is given by this expression. J diffusion electrons equals to product of Q dn by dx, where Q is the charge of electron, dn is the diffusion coefficient, and dn by dx is the concentration gradient. Let's find the dn value of capital Dn first. By Einstein's relation we know dn by mu n is equals to Vt. This gives dn equals to mu n times Vt. This equals to 1400 into 25 millivolts. So this comes out to be 35 centimeter square per second. So we got the value of dn. Now let's move towards concentration gradient dn by dx. This is nothing but the slope of this line, which we can easily find out. So this will be 10 raised to the power 16 minus 2 into 10 raised to the power 17 divided by, one more thing, this x-axis has the units of micrometers, while this concentration has the units of per centimeter cube. So let's convert this x-axis also into the units of centimeters. So this will be 4 into 10 raised to the power minus 4 centimeters, and this will be 10 raised to the power minus 4 centimeters. So this will be 4 into 10 raised to the power minus 4 minus 10 raised to the power minus 4. On solving this we will get minus 19 into 10 raised to the power 16 divided by 3 into 10 raised to the power 4. This comes out to be minus 19 by 3 into 10 raised to the power 20. So we got the value of dn by dx. We got the value of capital Dn. Now we just have to substitute these values in this equation to get the final answer. So the value of diffusion current density of electrons, J diff electrons equals to Q, that is 1.6 into 10 raised to the power minus 19 multiplied by capital Dn, which is 35, multiplied by negative 19 by 3 into 10 raised to the power 20. Let's solve this. 1.6 into 35 into minus 19 divided by 3 into 10. So this comes out to be minus 3546.67 amperes per centimeter square. One thing to notice is that we are supposed to answer this question in the units of amperes per millimeter square. So let's convert this from centimeter square to millimeter square. So we'll get minus 35.467 amperes per millimeter square. So finally this is going to be the correct answer to this question. I hope in the re-release of the official answer key they will correct this and the final answer will come out to be negative 35. Thank you so much.